Lunar Dawn, building a mining base on our celestial neighbor. The vision of humanity transcending Earth's boundaries, venturing into other celestial bodies, is no longer a distant dream of science fiction. It's becoming a tangible goal. At the center of this new era of space exploration stands the Moon, not just as a stepping stone to the deeper cosmos, but as a priceless resource in its own right. Establishing a permanent mining base on the lunar surface represents one of humanity's next giant leaps, a leap that could revolutionize our economy, our energy systems, and ultimately, our future among the stars. Why the Moon? A geological and strategic perspective. The Moon, our natural satellite, is a celestial body with a complex geological history shaped over billions of years by asteroid impacts and extinct volcanoes. This ancient past has left behind a wealth of potential resources, highly valuable for space exploration and colonization. The lunar crust is primarily composed of silicate minerals, such as plagioclase, rich in aluminum, calcium, and silicon, pyroxenes, containing iron, magnesium, and silicon, and olivine, which also includes iron and magnesium. These minerals point to the presence of elements essential for building infrastructure, manufacturing goods, and sustaining life. But it's not just about solid rock. The Moon's surface is blanketed by a layer of fine, powdery material called regolith, formed by billions of years of micrometeorite impacts and constant exposure to solar and cosmic radiation. And regolith isn't just dust. It holds a treasure trove of valuable elements, oxygen, hydrogen, present in water molecules and embedded into the soil by the solar wind, iron, titanium, silicon, and most notably, helium-3. The Moon's strategic location is also a game-changer. It's close to Earth, and its gravity is only about 1/6 of ours. That makes it an ideal launch site for missions into deeper space. Escaping the Moon's gravity requires far less energy than launching from Earth, dramatically lowering the cost of space travel if we launch from a lunar base. Lunar riches, what can be mined? Lunar mining focuses on two major categories of resources, those that support life and infrastructure on the Moon itself, and those that can be exported, either back to Earth or to future space missions. Volatiles, frozen water and helium-3. Water, H2O. Perhaps the most critical lunar resource is frozen water. Confirmed discoveries, such as those from India's Chandrayaan-1 mission and NASA's L-Cross, have revealed the presence of water ice in the Moon's permanently shadowed polar regions. Water is essential for sustaining life, for drinking, hygiene, and more. But its value doesn't stop there. It can be electrolyzed to produce hydrogen, rocket fuel, and oxygen, both life-sustaining and a powerful oxidizer. This means a lunar base could serve as a refueling station for deep space missions, eliminating the need to haul these heavy, expensive resources from Earth. Helium-3, He3. This rare isotope is found in abundance on the Moon thanks to its exposure to the solar wind, which the Earth's magnetic field deflects. Helium-3 is considered one of the most promising future energy sources. It's a potential fuel for aneutron nuclear fusion, a reaction that produces energy without long-lived radioactive waste. Although fusion reactors are still under development, the promise of clean, virtually limitless energy from lunar helium-3 is a powerful driving force behind the push for mining. Metals and structural minerals aluminum, Al. Found abundantly in plagioclase, aluminum is lightweight, corrosion-resistant, and an excellent conductor. It would be invaluable for building structures on the Moon, from habitats and launch pads to vehicles, reducing reliance on Earth-supplied materials. Iron, Fe. Present in ferromagnesian minerals and as tiny metallic particles in the regolith, iron is a fundamental structural material. It could be used to craft tools, machinery parts, and components for lunar bases. Titanium, Ti. Found in minerals like ilmenite, titanium is known for its high tensile strength and corrosion resistance. It's ideal for durable, lightweight applications like vehicle frames and equipment. Silicon, Si. Silicon is one of the most abundant elements in the lunar crust, and it's the foundation of modern electronics and solar energy. Extracting silicon on the Moon would enable the in-situ production of solar panels and electronic components, essential for powering the base and fueling future lunar industries. Rare earth elements. Though scattered in varying concentrations, the Moon may also contain rare earth elements like erbium, neodymium, yttrium, and lanthanum. These elements are critical to a vast range of modern technologies, from consumer electronics and electric vehicles to renewable energy systems. Finding economically viable deposits of rare earths on the Moon would be a true game-changer. Mining and processing methods on the Moon. Mining on the Moon presents unique challenges, requiring innovative technologies tailored to the harsh lunar environment. Some of the primary techniques will likely include regolith excavation, to extract surface volatiles and minerals. Autonomous robots and equipment would dig and collect lunar regolith. This could involve robotic excavators, drills, and material transport systems. Heating and volatile extraction. To release water and helium-3, the regolith would be heated in specialized furnaces. Water would vaporize and then be condensed, while helium-3 would be separated from other gases through cryogenic processes or selective membranes. Solid mineral processing. For metals like aluminum, iron, and titanium, metallurgical techniques would be required. Methods such as molten salt electrolysis for metal oxides or carbothermal reduction could be adapted to lunar conditions. Extracting oxygen from metal oxides like ilmenite would also be a valuable byproduct. Additive manufacturing, 3D printing. Once extracted and refined, these materials could be used for on-site manufacturing of parts and structures. 3D printing with lunar metals, ceramics, and polymers would enable the construction of habitats, tools, and spare parts without the need to launch them from Earth, which is incredibly costly. Powering lunar mining, energy will be a critical factor. Large-scale solar panels would be the main power source during the lunar day, which lasts about 14 Earth days. For the equally long lunar night, compact fission reactors would likely provide the most reliable solution, backed up by energy storage systems like high-capacity batteries or fuel cells. Benefits to humanity. A new era of prosperity. The benefits of a lunar mining base go far beyond resource extraction. They ripple across multiple dimensions of human progress. Sustainability and energy security. The promise of helium-3 for aneutronic fusion is one of the greatest drivers of lunar mining. If fusion becomes viable, lunar-sourced energy could offer humanity a clean, safe, and abundant power supply, freeing us from fossil fuels and the radioactive waste produced by current fission reactors. This would mark an energy revolution, one capable of transforming the global economy and curbing the effects of climate change. Space economy and cost reduction. Producing resources directly on the Moon, especially propellant like oxygen and hydrogen from lunar water, has the potential to drastically cut the cost of space missions. Instead of launching everything from Earth, spacecraft could refuel on the Moon, paving the way for more ambitious exploration of the solar system, including missions to Mars and beyond. This would spark a robust space economy, creating new industries, jobs, and investment opportunities. Self-sufficiency and human expansion. Lunar mining is a crucial step toward building self-sufficient human settlements beyond Earth. By producing water, oxygen, construction materials, and even food through lunar agriculture using recycled water and nutrients, lunar bases could become thriving hubs capable of supporting growing populations. This would allow us to expand our presence in space, transforming humanity into a multiplanetary species and ensuring the long-term survival and resilience of our civilization. Technological advancement and innovation. The extreme challenges of mining and processing resources on the Moon will drive innovation across numerous fields, including autonomous robotics, artificial intelligence, advanced materials, high-efficiency energy systems, and engineering for harsh environments. Extreme conditions. These innovations won't stay on the Moon. They'll lead to countless spin-offs here on Earth, driving technological progress and improving quality of life around the globe. Science and discovery. A permanent mining presence on the Moon would also unlock exciting new possibilities for science. Astronomical observatories could be built on the Moon's far side, shielded from Earth's radio interference, offering an unprecedented window into the universe. Meanwhile, deep geological studies of mining sites could reveal critical insights into the formation and evolution of the Moon, and, by extension, our entire solar system. Strategic resources and global stability. The ability to extract strategic resources, like rare earth elements and other materials essential to high-tech industries, could eventually reduce our dependence on limited terrestrial sources. This would ease geopolitical tensions, fostering global stability by making access to critical resources less vulnerable to disruption. Challenges. Ahead, the road to the Moon. Despite the massive potential, building a lunar mining base won't be easy. High upfront costs. The initial investment in research, development, and infrastructure will be enormous. It will require international collaboration and major funding from both governments and private companies. A hostile environment. The Moon is a harsh place, with vacuum, intense solar and cosmic radiation, extreme temperature swings, and abrasive lunar dust. Engineering for survival in this environment will be crucial. Logistics and transportation. Reliable, low-cost transport systems between Earth and the Moon and across the lunar surface are essential. Legal and ethical uncertainty. There's no comprehensive international legal framework yet for space mining or resource ownership. That raises complex questions. Who has the right to explore and benefit from lunar resources? Technological readiness. Many of the required technologies are still in development or need to be adapted to lunar conditions. Conclusion. A future. Written in the stars building. A mining base on the Moon is more than a scientific or economic venture. It's a declaration of intent, a testament to our curiosity, our ingenuity, and our drive to explore and thrive. The challenges are immense, but the rewards, clean energy, affordable access to space, self-sufficiency, and a new frontier of knowledge, are nothing short of transformational. As nations and private companies turn their eyes toward the Moon, the vision of a future where Earth is humanity's birthplace, but not its only home, is coming into focus. Lunar mining isn't just about what we can extract from the Moon, it's about what we can build for our future. A new era of prosperity, a new age of exploration, and, above all, a new chance to secure the long-term survival of our species in the vast untamed universe. The Lunar Dawn is near, and with it, the first light of a new era for humanity. Call to action for YouTube. If you enjoyed this video and want to stay up to date with the latest space news and insights, be sure to subscribe to the channel, ring the notification bell, and hit that like button. Share this with your fellow space enthusiasts, and let us know in the comments what you'd like to see in future episodes. I'm Commander Marcos, and this is Star Chronicles, where every shadow in space hides a story.